Hello all, this is experiment number 5 in structural design and detailing lab. So here this is about analysis and design of residential buildings subjected to secondary loads. So we have to consider seismic loads here. Let me show you. This is the building plan we have. This is a column layout. You can see according to the dimensions, there is 3 meter by 4 meter, 3 meter by 4 meter, 3 meter by 4 meter. And these are all the base are having 4 meter length and 3 meters width. You can see, and this is four gap is 4 meter, 4 meter, 4 meter, and this width gap is 3 3 3. And let us create G plus 3 building. So let us go to our start pro window. Let us create the file name as std lab number 5. So it is being saved in document and is fine. Choose the metric units as a metric. Let us create the one. The simplest method we have is a structure wizard. We can create it very easily because this is having very perfect model. Let us go to frame models. Before that, we have to check the units. Let us go to file tab, select units, choose as meters. Okay. And let us create the pre-frame. Double click on that. You can see the length. And what is it? 4 4 4. So 3 into 4, 12 meters. That is fine. Height is, so we are creating G plus 3. Then each floor height is 3 meters. 3, 3, 3, 3, 12 meters. And width is 3 meter, 3 meter, 3 meter, 9 meter totally. So number of bays along the length, 3. Number of bays along the height, so total height is 12. Each bay height is 3 meters. Each floor height is 3 meter. Width also 3 meters. Number of bays along height will be 4. Apply. So there is a frame, building frame we need to analyze. So let us go to file, merge the model with the start pro model. Yes. Okay. Now it is the frame we have created. Let us go to properties now. So in this you will be having an option like define or prismatic option. So here in this version, new version, prismatic option is there. Go to rectangle. We have to create the beam width as mentioned in the procedure. This is 0.3 is the depth of the beam, YD is the depth of the beam, ZD is the width of the beam. Width is 0.45. Add. Here it is added, right? So next we have to create 0.3 by 0.3 for column dimensions as mentioned in the procedure. Okay. Close. Let us choose the first one. We have to assign this to all the horizontal members. Let us go to geometry tab. Sorry, let us go to select tab. Beam panel parallel to X, parallel to shift. Now let us assign to selected beams. Assign, yes. So second one we have to go to beams parallel to Y, right? All the vertical members are selected. Assign, assign to selected beams. Assign, yes. Let us go to materials. We have to choose the even it is there concrete. We have to assign it again. Choose the concrete. Assign to view. It can be assigned to entire the structure here. Specifications, let us do not disturb this. So this is the sequence we are following, right? First we have created geometry where we have given skeleton of the structure. Properties, we have given the dimensions, sectional dimensions. Materials, we have chosen it as concrete. And then we are coming to, we are just omitting specifications and coming to supports. We have to create a fixed support for all the bottom nodes. So let us create fixed add. Okay, so choose the support tool and we have to create, select all the bottom nodes. For that, let us go to view tab, this front view, and select all the nodes by dragging. Assign to selected nodes, assign, yes. So let us go to this isometric view. Now you can see this, right? So now the supports are added. Let us go to loading. So in loading, we have to go to definitions, seismic definitions we have to go to add. So here we have to add generate the loads. So let us choose the code as Indian Standard IS 1893 Part 1 2016. Add it. Generate the loads. So let us choose any north eastern country. Let us choose Lucknow. So that gives okay, Lucknow. Let us choose this response reduction factor. This is a RC building frame with ordinary moment resisting force. Importance factor, we are coming to residential or commercial buildings. A soil type, we are choosing the medium soil. Structure type, this is all buildings with RC structure frame. Generate, add. So now we have added this load. Let us go to self weight. Already factor 1 add. And let us go to member weights. So in that uniform, so let us give the load weight as mentioned as 10 minus 10. Excuse me. Okay. As mentioned, this is weight is minus 10 kilonewton per meter. Minus 10. Add. So next let us add floor weights. This is a pressure. We are giving minus 0.75 as mentioned in the procedure. Kilonewton per meter square. We have to define Y range. There is a floor from 0 to, so we have actually 12 meters. So let us give another extra 13. Add so that it will be perfectly added to this. Okay, add, close. Now you can apply this member by to all the members here. Assign to view, assign, yes. Let us go to now load case details. Add. So we should always add when we have seismic loads, we have to add them at the first. This is seismic H that refers to the horizontal. So let us add the title as seismic load SL plus X. Add. Next second load case I'll giving as SL minus X. Add. Now we are giving SL plus Z. Add. SL minus Z. Add. Then we have to add the dead load. So change the title as dead load. Add. Now another load we have to add live load. Change it as live load. Add. Close. So let us, we have just assigned, given the loads, load names. We have to now assign the loads. SL plus X, add. Now you can see in this list, you can see seismic load in X direction, factor 1. SL plus X, right? So factor is plus 1 in X direction, add it. Close. Now we have to go to SL minus X, add. This is seismic load in X direction, factor is SL minus X, right? So minus X direction, it is moving to and fro. That means close. In SL, Z, X and Z represents horizontal plane, right? In this horizontal plane, it is moving. SL plus Z, add. So seismic load in Z direction, factor is minus 1. SL plus Z, add, close. In SL minus Z, add. Seismic loads in Z direction, minus 1 factor, add. We have assigned all the loads, right? Now we have to go to load case details. Again, we have to add the dead load. We have to add first the self weight already there. Self weight factor minus 1 in Y direction, that is fine. Add it, close it. That you have to assign it to view. Assign to view. Assign, yes. Another dead load we have to add. Wall load we have to add. So we go to dead load. Add. So we have to add wall load as a member load uniform force, that is minus 12. For external walls, we are giving minus 12 kilonewton per meter. Add is a minus 6 for interior. Close. So this we have to assign to all the exterior beams. For that, go to a view tab, go to top view, and very carefully choose all the external members. Now chosen, assign to selected beams, assign yes. Let us go to this -6 that we have to add for interior beams. Assign to selected beams, assign this. Let us now go to floor load. In dead load, choose the dead load, add. Okay, add floor load. Choose the pressure as -0.2, -0.2 kilonewton per meter square, and define Y range as 0 to outflow height 13 meters. Actually, it is 12. If you add 13, that will add perfectly to it. Now you can see in isometric view to see the float load. Let us add the live load. Add live load. We are adding it as floor load. Yes, floor load. And pressure, we are giving it as -2 kilonewton per meter square, and the Y range is as usual 0 to 13. Add close. Now you can see the live load is also being applied. Now we have assigned the loads also, right? Then we have to go to load combinations, load case details. So add. So here we have to choose auto load combinations, and here we have to choose the code as IS 456, IS 800. So starting from the combination 1. And here, okay, this is table number 8. Already it is automatically given. So let us do generate the loads. So these are all the load combinations we have. Now add close. You can see 34 combinations are added, right? So let us go to analysis. Analysis. Now we can go to yes, analysis commands. Choose all, add close. Pre-analysis commands, define commands, add all, add close. Post-analysis commands, define commands. So we have to shift the all loads here, add, go to analysis results, add, close, then run analysis. Okay, done. So let us go to post processing. So we have all these loads. So we can also see this moment forces. We can see reactions and beam results over here. Okay, we can first we can choose only one, and we can use the control and scroll it up in order to scale it. F5, choose F1 and select other, and choose control, press control button and scroll it up, and select this and choose the bending moment. Press control and scroll it up, so it will be zoomed. Otherwise, you will be having an option like view tab, label settings. Things you have to choose. Okay, let us cancel it. Let me show you. We have to go to results. I want to see displacement, all these results together. So go to select tab, mode, sorry, view tab, label settings, scales option, apply immediately. Now you can see bending Z. You can adjust the scale here manually. You can see shear Y, adjust the scale. Displacements, you can adjust the scale. Okay, now you can go to design directly from RCDC. Otherwise, you can go to this analytical modeling again, analysis and design. Okay, let us go to design, choose concrete, define parameters. Okay, sorry, here we have to choose IS 456. Now define parameters. You can see FC. Give it as 20,000. Add FY main reinforcement one penalty that is 000. FY secondary also 415 000. Add maximum main reinforcement we are giving it as 20 mm. Maximum secondary reinforcement 20 mm. Minimum main reinforcement we are giving it as 10 mm. Fine. Minimum secondary reinforcement 10 mm or 12 mm you can choose. Add. Okay, close. So let us add all these to the entire structure. Assign to you, assign yes. This, assign to you, assign yes. Choose 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 this, assign to view, assign yes. So let us go to commands. We have to design the beam, add design column, add design takeoff, add close. Okay, this design beam assigned to okay. We have to select the horizontal members. Go to select tab, beams parallel to X, parallel to Z. Assign to selected beams, assign yes. Design column, beams parallel to Y, assign to selected beams, assign yes. Okay. Now we can go for analysis again. Okay. You can see the output file always in utilities or analysis output. There you can see all the design results. Reaction loads, you can see the concrete design, beam column, all these details you can see. And another thing we have to go for, we can go for advanced concrete design. This is a design by RCDC. This window will be closed. A new window will be opened. RCDC, let us wait. Okay, here go to RCDC, accept. We have to fill the details, the project name, residential. Okay. We have to design the beams. There is no beam at the zero level, so we can go for all this, create a project. Similarly, you can do it for columns also. I will just show you the beams. Columns you can do it. So this RCDC will suggest the design on its own based on the dimensions we have given. So let us go to design. Go to auto design. So we have to shift all the loads here. You choose this, shift here. Choose this, shift here. Choose this, shift here. So we have shifted all the loads. Okay. Then combinations. We have already added the combinations in analysis, right? So add from analysis. Okay. Now you can see whether the beams are failing or not at this point, at this base. So it is designing group number 4. It will design all. Okay, now you can see all beams passed. You can see this green indication. So when the beam is fading, you can see red mark here. Then you have to go back and design the cross section again. So these are all the details of the beams. Group 1, Group 2, Group 3 up to and so on up to Group 8. So we can see the reports like we can see elevation and section diagrams. So for all beams we can choose. So cross section. So choose this all. You can have a better detailed design. So here you can see elevation. It is being developed. It is taking little time. Now the drawings were created. You can see elevation and section diagrams, how the reinforcement is provided. And these are the diagrams openable in MicroStation. There's also Bentley product. We can see all the reports like we can see the design summary. Here beam design summary you can see. Design calculations also you can see. So you can open any file you want. So for all beams, okay. You can see complete design process including the clauses of IS is a detailed design. You can see including the notations. You can see everything here based on IS 456. Here is also bar bending schedule. You can generate BBS even for all beams. You can give the details here. Maximum rebar length, start rebar number. You can choose all this. So I'm keeping them as usual. And it will now generate bar bending schedule including of course the diagrams of shapes of the bars what we have used. And these are of course the diagrams. So that is all based on if you just close it you can see you can see again now analytical modeling part. This is a whole structure. It was analyzed based on StatPro and RCDC. Thank you.